we're stepping inside a modern dairy processing plant. Imagine a place where, the chaotic, organic nature of a farm it meets the absolute rigidity of high-tech engineering.
It really creates a fascinating contrast. I mean, we are talking about miles of stainless steel piping massive towers and
a level of control that honestly borders on the microscopic.
Yeah, exactly. In this deep dive, we are tracing the journey of raw, perishable milk as it is transformed into shelf-stable condensed milk and powder. It is not just cooking, it is precision manufacturing.
Let's begin at the raw milk reception stage, because the mission starts the second that milk hits the loading dock. We're not just pouring buckets here.
No, the very first engineering hurdle is thermal control. That milk has to be maintained strictly between 36 and 40 degrees Fahrenheit.
Right, because if it drifts out of that range,
the bacterial load increases exponentially. The whole batch could be compromised before we even start.
Okay, so once it is in, and cool, we have to clean it up. Next comes clarification and filtration. But we aren't using some simple mesh strainer.
Not at all. This is where we see the first major piece of technology: centrifugal clarification. We are spinning the milk at incredible speeds. The physics here allows us to separate heavier impurities and somatic cells just using density and G-force.
It just pulls them right out of the liquid. So we have clean milk, but we want that velvety, consistent texture. We don't want the cream floating to the top. Now we move into homogenization.
This relies on high-pressure homogenization. We are pushing this liquid through tiny valves at 2,000 to 3,000 psi.
Wow, that is a massive amount of force. That's enough to physically alter the structure of the liquid.
It shatters fat globules into microscopic particles so small they literally cannot float to the top again. That brute force applied with extreme precision is the only reason your product stays uniform on the shelf.
Makes sense. Now at this stage, evaporation becomes critical. We need to get the water out, but we can't just boil it on the stove.
Right.
It'll taste cook.
And nobody wants that. We have to use vacuum science. By lowering the pressure inside the vessel, we actually lower the boiling point of water. We can boil the milk at just 40 to 50 degrees Celsius.
Which preserves those heat-sensitive proteins and vitamins, right? The ones that would be totally destroyed at normal boiling temperatures.
Precisely. And we rely on multi-effect vacuum evaporators. These systems are often paired with vapor recompression technology, which captures the steam boiled off the milk and recycles it to heat the next batch.
Turning waste heat into energy. That's brilliant. Now, if we are making sweetened condensed milk, we have to add sugar. But looking at the chemistry, it's not just for taste, is it?
No, it acts as a very specific preservative mechanism. We're aiming for a precise sugar concentration of approximately 45%. This increases the osmotic pressure so much that bacteria simply cannot grow.
It just dehydrates any microbe that tries to survive.
Yeah.
And to make sure the concentration is perfect.
They use inline density sensors. These monitor the thickness of the product in real time, ensuring it is exactly right before it ever leaves the tank.
But let's say we aren't making condensed milk. We want milk powder. The process diverges drastically here.
It does. We move to the spray dryer. Visually, this is the most dramatic part of the plant.
It really is. It's liquid turning to dust in seconds inside these massive towers.
The engineering here focuses on spray drying atomization. We blast the concentrate into a mist inside a chamber where the inlet air temperature is between 180 and 220 degrees Celsius.
Because the surface area of the mist is so huge, the water evaporates instantly.
You go from a liquid to a powder with just 2 to 4% moisture in the blink of an eye.
That's incredible. Finally, rigorous quality control ensures consistency. We have this perfect product, but we need to make sure it is completely safe.
This is the non-negotiable part. For canned products, we use retort sterilization heating cans to 240 to 250 degrees Fahrenheit for up to 20 minutes.
And for the long life cartons?
We use UHT treatment. Ultra high temperature, hitting 280 degrees Fahrenheit for just a few seconds.
Getting it into the package safely matters just as much.
We rely on aseptic filling systems. For powders, we might even use nitrogen sealing to push out oxygen and prevent oxidation. It ensures that the engineering effort we just described lasts on the shelf for years.
So what does this all mean for you listening? We have gone from a raw biological product to an absolute feat of chemical engineering.
It highlights how much energy goes into things we take for granted. Next time you pour that creamer into your coffee, think about the vapor recompression technology that made it possible. Sustainable engineering is the only reason the global dairy supply chain functions the way it does.
Definitely something to chew on with your morning brew. How the invisible engineering behind your food is just as crucial as the farm it came from. Thanks for joining us on this deep dive.